a rigid body. Every particle is to move with same velocity. But that is what not I am of the opinion. What did I say? I said that it is liquid and liquids are to move in layers. Clear, yeah?
Yes, sir.
Yes,
So
sir.
one small doubt. If we take one entire,
Yes, Krish.
if we take an entire concrete slab of water, as you told, say
Yeah.
one slab, that time
Yeah.
it'll be non-viscous liquid, no sir?
Then there will be non-viscous. Then it doesn't sound sense relating it to viscosity, Krish.
So that means if we take a small drop,
You said concrete, it cannot flow, right, Krish?
yes sir,
So it doesn't cut eyes to relate it with something which can flow.
okay, yes
So
sir,
it's a non-brainer, it is a non-starter. It will not be under the bracket fluid taken. Why is concrete to us?
okay,
Got it, yeah? So when I'm talking of bulk concrete, so of course it will be, if I want to, no, fine. If I say, no, I want to treat it as a fluid and I'll be taking it as viscous, non-viscous, that you want to decide. Of course, you will say it will be what? Every layer is moving with same speed, correct? Every
Yes, sir.
layer is moving with same speed. If you are taking it to be layers, in different layers. So every layer is moving with same speed. If every layer is moving with same speed, that means no layer is rubbing the other layer, correct?
Yes sir,
Yes,
And
sir.
if no layer is rubbing the other layer, then there will be no relative velocity between layer, correct?
yes sir,
And if
Yes,
there
sir.
will be no relative velocity between layers, then there will be no loss of energy, correct?
yes sir,
Yes,
Yes,
sir.
sir.
No loss of energy. What kind of material it is? It is non-viscous fluid. Clear idea?
so if we take a small drop of water,
Uh-huh.
so will it also be viscous?
Again, small drop of water, can it flow? Can it flow?
So
By
considering it can,
flow, what I mean? By flow, I don't mean transfer. See,
okay,
dynamics and statics, I told you I'll be coming to. Since you have asked me this question, I am taking a preemption on the same. And that being, if I take a bucket and move bucket which is filled with water and move bucket, is it okay?
yes
Then
sir,
what I am doing, I am making water move. Water which is in bucket, I am making it move, correct?
sir,
So will I treat this experiment as flow of water? Will I treat this experiment as flow of water? Think about it, and then you will relate to
No,
it.
sir.
Taking a bucket is moving. I'm moving bucket, and I'm not stopping. I'm incessantly moving the bucket ad nauseum. It is moving with some velocity. Fine, Trish.
yes sir,
And then I ask, can I say water is flowing in bucket, or can I say water is flowing?
no,
No, sir.
Sir.
You cannot say water is flowing. Why? Because water is being moved as bulk.
yeah,
Water is being moved as bulk. It is not that water is moving in layers. You have moved water, right, Krish? But you
yes sir,
moved it as bulk presence. Say yes or no.
yes sir,
You didn't make it flow. You didn't make it move in layers. If you make it move in layers, then you say water is flowing. So if that is not getting established, first experimentation will be studied under the heading statics. Are you getting it?
yes sir, yes sir,
Yes,
When you
sir.
make it flow, then you will move from statics and go beyond it. We'll then treat it as dynamics. So that is the distinction between statics and dynamics. You are not to say over here that water is flowing. You can say water is moving. Of course, water is moving and moving in bulk. But water is not flowing. You will refrain from saying it is flowing, right, Krish?
yes sir,
So when you talk of water droplet, what is happening? Is water flowing in it? Is
no,
water flowing in water droplet? Say me yes or no, Krish.
so no sir,
The water is not flowing. Droplet is moving as bulk of water, right?
yes sir,
So under what heading we are to study this? Not
yes sir,
dynamics, but statics. Clear, yeah?
yes sir, you got it.
Okay. So now when I'm talking of viscosity, see, viscosity comes when we study flow. Okay, not before of that. But I have used the term, and that term is to be used by any teacher. As we begin with, we are dealing with fluids which are non-viscous and incompressible. Incompressible is easy to understand, but for viscosity to make you understand, I'll have to take flow of liquid. Correct, yeah?
Yes, sir.
Yes, sir.
And
Yes, sir.
when liquid flows, the best example will be take river flowing. Correct, yeah?
Yeah. Yes,
Yes,
And
sir.
sir.
you know very well that the boulders which are at bed of river, the boulders which are at bed of river, they will also move, but will they move with the same speed as that of the boat on the surface of river? Say me yes or no. You have kept two boats. Okay, let me be even on the front of object as well. You have got two balls. Okay, one is kept at the bed of river, and the other you are maintaining on the surface of river. Correct?
Yes,
So I
sir.
don't
Yes,
understand.
sir.
So two.
We have got two rafts, Krish.
Okay. Yes.
Okay, we have
Yes.
got two rafts. One is kept on the surface of river, and the other is kept at bed of river. Correct? Yeah.
Yes, sir.
Okay, they are of same weight, different density, but same weight. Correct?
Yes, sir.
Okay, now tell me. If I'm to ask you about their speed, what you are to say? The speed of raft which is apparent to you is same as speed which is at the bed of river, or they are different?
So they're different.
Different.
Which will move faster? Which will move faster? The one which is on the surface, or the one which is at the bed of river, touching the bed of river? Which will move faster?
The one is the
The one
surface.
is at the
The
surface.
one which is at the surface. Obvious, the one which is at the surface. Tell me yes or no. The one which is
Yes,
apparent to
sir.
us, correct?
Yeah. Yes,
Yes,
sir.
sir.
Yes, sir.
Which is apparent to us will move faster, which is then to be inferred, moving with highest speed, correct?
Yes, sir.
Yes, sir.
Yes, sir.
As you move down, if I am to take a cue from here, can we say as we are moving down, we are to see speed of layer getting abated. Can we say that?
Yes, sir.
Yes, sir.
Layer getting abated. Can we say that? First layer highest,
Yes,
then layer,
sir.
then layer. So what is happening? Incessantly the speed is getting abated. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So you can also relate to a boulder which is touching earth, which is at the bed of river. You can say it is at the bedrock and it will not move. That is
Yeah.
what is called
Yes,
Yes,
bedrock, right?
sir.
So
yes,
it will
sir.
not move as well. If it is heavy, it will not move. So much so that we can say that the layer, and we will be taking this. That's the reason I am making this disclaimer right away. We will be taking this very often. So please do relate to it right away. We will be taking the surfaces which are in touch with immovable object to be at rest. Is it okay? The surface
Yes,
of
sir.
liquid which are in touch with immovable objects, we will be assuming that layer, that surface of liquid also to be at rest. Is it okay?
Yes, sir.
yes, sir.
Yes, sir.
So I'm pre-barricading your question. Of course, we know that it is not possible for any surface of liquid to be at rest. Correct? Howsoever small be the speed, yet it will be moving, right? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, fine. It is moving with snail speed. It is inching, yet it will be moving. That is a given. But in questions which I'll be solving, so let me find virtue over here. In questions that we will be solving, the portion or layer of liquid which will be touching immovable object will be taken to be at rest. Am I clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so that disclaimer I made already. Let me ask you then, can I assume this layer to be at rest? Going by the
Yes,
same
sir.
conjecture,
Yes, sir.
going by the same conjecture and surmise. If I go by the same surmise, same conjectures, can I assume that this layer is at rest?
Yes, sir.
Yes,
And
sir.
as we are moving up, it is getting accentuated. Speed is getting accentuated. Can we say that?
Yes, sir.
Yes, sir.
Okay. So this is how speed will change. Thereby, we are of the opinion that one layer is rubbing the other layer. Say me yes or no?
Yes,
Yeah.
sir.
Yes.
And if one layer rubs the other layer, then of course the layers are to apply force of friction on each other.
Yes, sir.
Right,
Layers
sir.
are to apply force of friction on each other. And if layers are to apply force of friction on each other, then to overcome friction, energy will get lost, correct?
Yes, sir.
Yes, sir.
So there is a loss of energy. When non-viscous liquid flow, then there is loss of, sorry, when viscous liquid flow, then there is loss of energy. Is it okay?
Yes, sir.
Yes,
Why
sir.
is there having loss of energy? Different layers which are rubbing each other. Can we say that? Different
Yes,
Yes,
layers,
sir.
wafer thin layers, but they are rubbing each other. So there will be loss of energy whenever we associate layers and layers moving with different speed. Then to that fluid, we are to associate loss of energy. Can I say that?
Yes, sir.
Yes, sir.
Yes, sir.
We cannot apply conservation of energy principle to those fluids. Remember this class. We cannot
Yes,
apply,
sir.
I tell you, conservation of energy cannot be applied to those fluids. Fine.
Yeah. Yes,
Yes,
sir.
sir.
Yes.
So if we cannot apply conservation of energy to fluids, then we can never use Bernoulli's theorem. You'll be studying in flow of liquids about a theorem which will be called Bernoulli's theorem. And Bernoulli's theorem is nothing but an extension of work per energy under the principle that there is no energy lost when liquids flow. Clear, dear?
Yes, sir. Yes,
So if I
Yes.
am of the opinion, if I have began with the premise that there will be no loss of energy, thereby supplementing it with Bernoulli's theorem, what can we say about Bernoulli's theorem application? It applies to only what kind of liquids?
Non-viscous.
Non-viscous.
Are you getting it, dear? Are you
Yes,
getting
sir.
it
Yes.
now?
Yes,
Okay.
sir.
So with this, what we can say that unless stated otherwise, we are to assume that liquids, even if they are to flow, it will flow in bulk. That means every layer will flow with same speed, correct?
Yes, sir.
Yes, sir.
Layer is flowing with same speed, then we can very well associate conservation of energy with the flow, correct?
Yeah. Yes,
Yes,
sir.
sir.
Why? Because there will be no loss of energy in overcoming friction, as there will be no friction seen owing to there being no rubbing of the layers, correct?
Yes, sir.
Yes, sir.
So is your understanding on the two words clear?
Yeah.
Yes, sir.
Yes, sir.
Incompressible clear, all of you, Vedant? Incompressible?
Yes, sir.
Density will not change. Howsoever we want, we can change pressure to whatever we want, but density will not change. Correct, yeah?
Yes,
If I compress gas, I can change its density. Say me yes or no. If I compress gas, I can change its density. Say me yes or no.
Yes,
Can
Yes,
you?
sir.
Yes.
Okay, but we are talking of over here of those fluids which has got no inkling with pressure. Clear?
Yes, sir. Yes,
Even
Sir,
with
but
pressure, density will remain the same. Am I clear here?
Yeah. Yes, sir.
yes, sir.
So they are incompressible to us. Then the second one, non-viscous. Non-viscous means when liquids flow, they flow in layers and each layer is moving with same speed. Correct, dear?
Yes, sir.
Yes,
So
sir.
there is no rubbing off layers. Am I clear on this?
Yes, sir.
Yes, sir.
So never lose sight of these words: incompressible and non-viscous. Fine.
Yes, sir.
Yes, sir.
Okay. And fluids, you know. Now I used a term, and that term was pressure. I have used a term, and that term was pressure, isn't it? I told something about pressure. Did I?
Yes, sir.
Even if I told you that even if you increase pressure, isn't it? I told you about it,
Yes,
correct?
sir.
So
Yes, sir.
let me ask you about what to you is pressure and how it relates to fluid, in particular liquid. How it relates to liquid, because you have watch nowadays with pressure being marked. It is being in the watch displayed that you can go up to depth of 10 meter, 20 meter, 30 meter, right? Yeah.
Yes, sir.
Yes, sir.
So that is basically an indication of what pressure your watch adhesive can bear before water starts seeping. Clear, dear?
Yes, sir.
So that is basically measurement on the adhesive strength of material that watch is made up of. Got it, dear?
Yes,
Yes,
sir.
sir.
So let me ask you on, if it is so, then in what ways pressure relates to fluid or liquid to be particular? Fluid at large, but liquid to be particular. Okay, fluid, why I'm not relating to fluid, because air, if you'll say, it hardly matters. The pressure change due to air is meager. And Asivama cites an example of Golghar, which is there in Patna. He says that you are at the base of Golghar or you are at the top of Golghar. By the way, Golghar is good. I presume it is around 6 to 7 storage kind of a building. It is a greenery storage building, and it is round in structure. Vedant will be able to relate to it. Right, Vedant? So that Asivama uses this language that even if you are at the bottom of Golghar or at the top of Golghar, air pressure will remain same. And we will learn about how to calculate pressure. I'm not relating to air pressure. Reason, it hardly varies. You are there at the foot of 14 storage building or at the top, air pressure is almost the same. It's almost even. But when you talk of the same with swimming pool, when you talk of the same with swimming pool, if you are at the top of swimming pool and if you are at the bottom of swimming pool of depth 10 meter, there is chalk and cheese difference between pressure. Is it okay, dear?
Yes, sir.
Okay. Chalk and cheese difference between pressure. And why is that difference? As I've told you, I'll be coming to it. But before of that, let me get from you your understanding on pressure. What is pressure? A scalar or a vector quantity?
That's
Is pressure a scalar or is a vector quantity?
is a scalar.
Okay, it is scalar quantity. And what is it defined as? Force by area, correct?
Yes, sir.
By the way,
Yes, sir.
later you will study that force is a vector quantity and area is also vector quantity. So it is basically one vector divided by the other vector, isn't it? So tensor and all will come in picture, but let us not go there. For now, we know that pressure is a scalar quantity and let us stick to this concept. Fine, yeah?
Yes, sir.
Yes, sir.
Pressure is a scalar quantity and we define pressure as force by area, right? Yeah?
Yeah.
Yes, sir.
Let me get you a tumbler, and tumbler being filled with water. I want pressure over here. So in order to calculate pressure, you will ask me to get you an area, right? Tell me yes or no.
Yes, sir.
You will
Yes,
ask
sir.
me for the area because you relate pressure with area. So you'll ask me which area you want me to calculate pressure on. I get you the area. I get you this. I want this area. over which you are to calculate pressure. You will say, okay, what you will do after of that? You will take force perpendicular to this area, isn't it? Yeah.
Yes,
You
sir.
will take
Yes,
force
sir.
which is perpendicular to this area, and then what you will do? You will divide that force, the perpendicular force. I'm writing it this way. Find here.
Yes, sir.
Yes,
You
sir.
will divide that force by area of your taking or area of my tendering. Clear? Area
Yes,
that
sir.
I have. Got here?
Yes, sir.
Yes,
You
sir.
get pressure equation as force by area. Good enough. The other person whom I have asked about pressure again, but given a different orientation for area, he calculates pressure on the second area shown here, visible,
Yes, sir.
Yes, sir.
and his pressure equation being the perpendicular force to this area divided by this area. Find here.
Yes, sir.
Yes, sir.
Yes, sir.
Then I ask you for pressure not on individual areas, but at a point. Getting it here? Then
Yes, sir.
I ask
Yes, sir.
for pressure not on area, but at a point. And which point I ask both of you? A point which is common. Am I clear? This point. This point is housed by first area and also by second area. It's a common point. Clear here?
Yes, sir.
Yes, sir.
Yeah.
So I ask you, forget about area that I have tendered. You get me for the point. What is pressure at that point? Be point specific, quantificate it. So you ideate for a while, and then we are coming to the conclusion, okay, we can find, provided we take force and divide it by area, and then say that area is tending to 0, correct?
Yes, sir.
Yes, sir.
We are assuming that the area shrinks and shrinks to a point. Clear, dear?
Yes,
What did
sir.
we
Yes,
assume? Area shrinks and shrinks to a point. Am I clear, Adesh?
Yes, sir.
Okay. So area shrinks, area A shrinks and shrinks to a point. Area B also, or the other area that I have taken by prime notation, A prime, that also shrinks and shrinks to a point. Clear, dear?
Yes, sir.
Now
Yes, sir.
I do have a problem. And the problem being, both the areas did shrink to a point.
Yes, sir.
Right, dear?
Yes, sir.
Yes,
Area
sir.
shrinks to point. Area A prime shrinks to point. Both the area shrink to point.
Yes, sir.
And if both
Yes,
the
sir.
areas shrink to point, look at, see for yourself, please. Both the areas shrink to point. Yes or no?
Yes,
A
sir.
shrinks.
Yes, sir.
A prime shrinks to. So both the areas shrink to point. If this is the case, then pressure at a point cannot read different, correct?
Yeah, yes,
Yes,
sir.
sir.
Yes,
What
sir.
area you have taken area A or taken area A prime, when they are to shrink to a point, then they are identified by that point. Yeah.
Yes, sir.
Yeah, yes,
And if
sir.
identified by that point, pressure at a point cannot vacillate. Will it keep on vacillating?
No,
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 it will
sir.
not. Till the time we disturb, it will not. Clear, dear?
Yeah.
Yes, sir.
Yes, sir.
So as we are not disturbing, this liquid is comfortable in its skin, we are not disturbing it, it is tranquil. Then what we are to say? We are to say that pressure at this point should be point specific, should remain whatever I have calculated by first or second. It is no way to relate it. Pressure should read 1. Pressure should be unilateral at that point. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So what do we get to see from here? What are we inferring of all our lecture sermons is pressure is independent of area's orientation. Clear, dear?
Yes, sir.
Pressure
Yes, sir.
is independent of orientation of area. So what you are beholden by, as you asked me initially, which area? Your question, correct? Yeah.
Yeah.
Yes,
Yes.
yes.
We are liberating ourselves of area behold. Clear, dear? We
Yeah.
are liberating now. We are liberating ourselves of it having an affiliation with area. Am I clear, dear?
Yes, sir.
Yes, sir.
Yes, sir.
We are to henceforth say, we are to say pressure relates to point, not area which houses the point. Clear, dear?
Yes, sir.
So pressure is area specific or point specific. Which one you have to pick?